Perspective. You're talking about perspective. I get it.
Good. Don't ask stupid questions about why you can't see the Eiffel Tower forever. We've got perspective. Your curve maths thinks you can see forever because it's hijacked that effect and called it Earth curve. Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate.
Well, I'm trying to get to that guy. There was a guy in the pre-show that had some questions. He was asking about, what was that? Eclipses? I thought he was going to have something in the live show. Is he still around?
Yeah, he's right there.
Yeah, I am here. Yeah, I am here. I'm here, sorry, yeah.
Well, what have you got, buddy?
I mean, I have a question, but it seems it's too silly for us to Nathan, so I just kind of avoiding it and just listening to the discussion. That's it.
You can ask. We don't mind answering.
Okay, so so this might sound silly, and you may shout at me. So I'm just gonna put this out right there. So if Earth is flat, why are we just seeing beyond the curvature of the Earth, but not just too far? Like if I live in US, I should have seen the Eiffel Tower in Paris. Like why am I not like I know this is far beyond the curvature of the Earth, but if Earth is really flat, why are we not seeing the Eiffel Tower?
Too small.
Have you ever
Do you
heard
think you have unlimited line of sight?
Too small.
Oh, of what?
You understand things get smaller the further away you get from them, right?
Yeah.
Right.
It's too small.
So
You know what
once
Right, and
So you, I mean, we are seeing stars and moon, which are like hundreds of kilometers away from us,
Are they?
or miles.
are they?
Are they?
Hold
How
on.
do you know that?
Yes,
Are
We
they?
don't know that.
because on an eclipse day, me and my friend had a telescope, and we have seen moon, which is really far, and we have seen which is close to us. At least moon, not the stars, but we have seen moon, which is at least like 23,000 miles from here.
Why? Because you say so.
But
can
US to
can I
Paris
take this?
is
Continue?
like 4,000 miles.
Yeah, on flat side. Feel free.
Sorry. Okay. If it's so far, then why is it with my iPhone 6 I can zoom into the moon?
What?
I can use my iPhone 6 and I can zoom onto the moon. If it's so far, how do I get that right?
I mean, you can zoom on to the moon with your iPhone. Yes, you can, but you won't
But
get
I
as much
can't-
clarity as you
but
watch
my
in a
iPhone-
telescope.
But my iPhone can't zoom a mountain that's 2 kilometers away. How's that work?
I mean, see,
Trying to
if I
say the
use the
moon is
same
not as far
telescope
as
that I
you think
saw,
it is.
Okay, look, you gave us a number.
You understand?
You gave us a distance. How do you know how you've
Yeah.
got that number?
the distance between the Earth and Moon.
Yeah, you just assumed it. You threw in that it was that distance. Do you know how you've got that number, though?
They predicted it. The astronomers years ago, they predicted it.
Sorry, we're talking about measuring things. Predicted? No, you don't make predictions about... You measure things. That's how you measure distance. With a tape measure. You can measure things. You know how to measure? That's not a prediction.
Yeah, I know.
Okay, so where'd you get that distance? You're assuming it's a very far away thing. And you're saying, well, I can see that. Even though your original question was, why can't I see the Eiffel Tower? We answered, it's too small. Now, can we just cover that first before we move on to where you've got your moon distance? We know where you've got that distance from. It would seem you don't.
Yeah. I'm being honest. I didn't find the distance between Earth and Moon. I looked it on the internet. I'm being honest about that. But if Earth is like flat,
Stop!
how flat is the Earth?
Stop asking us questions. Don't scattergun us. So let's get some concessions. First and foremost, you asked about why we can't see the Eiffel Tower, and you assumed it was behind a curve of the Earth. You made that declaration as part of your question. Then we answered, it's too small. Now I'm going to ask you, why would you assume that there's a curve of the Earth, a physical blockage between things that you see in the distance and yourself? Why would you assume that?
Because I don't see that far away.
The things are too small.
Do you think that's my...
Let's try again. I'll try slower. First, concede what I say. Don't ignore it. Don't just assume your sphere edge has got in the way when we've answered your question about the Eiffel Tower. Why can't I see it? It is too small. Do you understand that things get smaller as you get further away from them, eventually becoming too small to see, like the Eiffel Tower at a distance? It's not automatically behind a physical Earth curve edge that boats fall over. That's absurd. I'm telling you, not asking.
Okay.
It gets too small to see. Do you understand and concede this so we can move on? Not ignore it.
That Eiffel Tower is too small. But what about a Mount Everest? It's the largest
also
spot on
can
the
get
entire
too
Earth.
small to see. Do you understand that it doesn't just apply to the Eiffel Tower now? It seems that I've got to take baby steps with you. Not only the Eiffel Tower, but anything you look at gets smaller as it gets further away. We could list everything. We could go through all sorts of buildings and mountains and structures, but we just prefer you understood and conceded at this stage that things can get too small to see. How long is this going to take?
None at all. Thank you for answering the question. I'm done.
You haven't. So it's just ask us something and then bugger off when we ask you something. So no concession, no I understand. You asked us a question that we've answered and you've not replied to that. Why doesn't the Eiffel Tower get behind Earth curve? Oh, well, Earth curve's an assumption that would require physical geometry, and we debunked that with the Black Swan. So your declaration that it would somehow be behind Earth curve, we've debunked that. Now, obviously, you're not in the slightest bit interested in responding to anything I've got to say, only in asking us questions and then running away when we ask you something. So do you understand that the Eiffel Tower gets too small to see? The same would apply to a mountain or anything else you describe. It's not going behind a physical edge that boats fall over. That's your globe Earth edge physical horizon. That's not happening. Maybe just not respond to anything I've said? Too difficult to talk to, Nathan, right?
Yeah, you're shouting, that's why.
I'm not shouting, this is my normal tone. This is how I talk.
You said you don't interrupt, so I'm not interrupting. So when you're finished, then I'll talk.
Okay.
And I agree with you. Things get too short when you're too far. I get it.
Excellent.
I get it.
So not going over a presumed sphere edge. Boats aren't falling over an edge of the globe. Just getting too small to see. You've just told me that you won't interrupt, so now you're continually bloody interrupting me. You don't have to nod along while I'm talking, saying yes, yes, yes. That cuts my line. Thank you. So boats are not going over a sphere edge horizon. This physical geometric sphere edge you think boats go over and blocks things like the Eiffel Tower? They just get too small to see. They converge at the horizon. It's a convergence point. It's not a physical sphere edge that you assumed. Can we get a concession on that too? Maybe debate about it.
Yes, so according to you, how tall should a thing should be so you can see it from any distance? How tall, according to you, it should be to see the other corner of the planet?
How tall something's got to be to see it forever? No, there's something called an angular resolution limit based on the aperture of the thing you look through. Telescope, eyeball, camera. They've all got an aperture size. That dictates how big something will be. It's calculated with the Rayleigh criterion. Is this something you're familiar with?
Yes, I am. So hang on. So a telescope makes it 1,000 times more closer, right? That's what telescope is made for. So if I point it towards France from US, a telescope, even though I won't see it, right? Even though I won't see an Eiffel Tower, which makes the telescope 1,000 times more closer to a thing that which is too far. So why am I not seeing through a telescope?
Just explained the angular resolution limit based on the aperture calculable with the Rayleigh criterion, something you acknowledged as knowing, and then went on to ask me precisely what would be answered with the Rayleigh criterion that you said you understood. So you don't understand it, you lied. Otherwise you wouldn't be asking me that question. It's an absurd question if you understand diffraction limit. What's diffraction?
No,
And let's have a go at a fundy fuckwit for a change. What's diffraction?
I know what a diffraction is, but
What is it?
A diffraction is a turning, is a bending or a
No!
turning of a wave, such as light.
I get so much shit about this. You don't know what diffraction is, and yet you're asking me and telling me you know what the Rayleigh criterion is. This is the diffraction limit. You don't even know what diffraction is. Why are you asking me with your assumption that an Earth curve edge, which we've debunked with the black swan, gets in the way, and presuming that you can see the Eiffel Tower forever? That's absurd. It's so stupid. Why would you think that you can see things forever? You've got an angular resolution limit. The point that things diffract. Why are you talking through me? You fundy moron. You don't know what diffraction is, you complete idiot. There's a limit that you can see things at. The point that they disappear. The point they diffract. The point that you have interference. That limit is calculable with the Rayleigh criterion. Maybe look into it. Rather than asking me why you can't see the Eiffel Tower forever, it makes you seem like an imbecile. Things get too small to see, you imbecile. Now answer me this. Why would you assume that boats go over the edge of a sphere, blocking them from bottom up? Why would you assume that? Given that you don't understand that things can disappear into the distance with an angular resolution limit at the point they diffract. You don't even know what that word means. I get accused of not knowing what diffraction is, even though I've been detailing it for 3 straight years. The reason people come to me and ask me what diffraction is because I get people like Conspiracy Cats on Tony's channel fundy muting the shit out of me when it takes quite a considerable period of time to explain to an arsehole what the diffraction limit is, and how it destroys the fundamental premise of your Earth curve geometry, which ignores this limit, where things diffract. Now that's completely ignored in your Earth curve geometry, yet you've told me Earth curve gets in the way of the Eiffel Tower, having absolutely no knowledge of things diffracting into the distance. It's absolutely pathetic. Do you feel stupid? You should.
No.
Why not? You don't know what diffraction is. You don't know what the diffraction limit is. You don't know what the Rayleigh criterion is. You're asking me why I can't see the Eiffel Tower forever. It's too small to see. Now, the fact that you would ask such an absurd question makes me think you're an imbecile.
Nathan, that's not a diffraction limit. It's
what is
called
the diffraction
limited system. That's the full name of it, and the resolution of an optical imaging system, a macroscope, a telescope, or a camera. And eyes can see until an infinity distance. I can see stars.
You can't see an infinite distance. You stupid moron. No, you cannot. There is a diffraction limit, calculable with the Rayleigh criterion. You are stupid. You cannot see an infinite distance. However, if you translate your world into an orthographic view, where you're standing side on to something you're observing, and draw a straight line between the two, as is done in Earth curve geometry, then it would imply that you could see forever, because the size of the thing you're observing doesn't change its actual value. That would be feet or meters. So it doesn't matter how far you draw the line between observer and target. In Earth curve geometry, you can see an infinite distance. And that's why you think you can see an infinite distance, because you are ignorant of diffraction limits. That's why you think you can see forever, because in your world, the feet and inches value of a target never changes. Implying you can see forever? Well, that makes you stupid. You can't see forever. There's a diffraction limit, you stupid idiot. No? No response? Were you unaware of this limit you lied about? Rayleigh criterion?
I mean, I've heard about refraction, but I never heard of diffraction. Yes,
you asked me if it was light bending. You haven't got the slightest clue what these words mean. You are the kind of person that asks me why you can't see the Eiffel Tower forever. Like, literally, that is so stupid. I hope you feel stupid with your religious belief that boats go over an Earth curve edge based in geometry that allows you to see forever because it's hijacked perspective and calls it Earth curve. Something you are completely blissfully unaware of. Yeah, things get too small to see, moron. It's not Earth curve getting in the way because you can see forever and only Earth curve obstructs things in the distance. That's not what happens. So, my friend, we do have a diffraction limit, calculable with the Rayleigh criterion. It's not that we can see forever as per your geometric maths that uses feet and inches for a target, implying you can see it at any distance. A million miles, who cares? My friend, you are completely blissfully unaware of diffraction limits. Rayleigh criterion, things getting too small to see. Why are you even here asking me questions about why you can't see things? That's stupid. Why ask me why you can't see the Eiffel Tower forever? That's a stupid question. That only somebody who believes they're on a sphere and can see forever because their maths takes place in orthographic view would ask that. Just because you're blissfully unaware of this thing called perspective.
Perspective. You're talking about perspective. I get it.
Good. I don't ask stupid questions about why you can't see the Eiffel Tower forever. We've got perspective. Your curve maths thinks you can see forever because it's hijacked that effect and called it Earth curve.